Okay. So the closed loop transfer function of a system is given like this. Okay. So this is the transfer function given for the closed loop system. They are asking the number of poles in right hand RHP and LHP they are asking. So right hand poles and left hand poles. Okay. So which of these lies at the left hand side and which of these lies at the right hand side. Okay. First of all, how many poles would be there? So since the order of the equation, characteristic equation is 5, so 5 poles would be there, right? Now how to find that? How many poles are at the left, how many at the right? Now we don't need to solve this equation to find the poles, right? Because order of 5 equation, solving of this order of equation would be very difficult and it will consume a lot of time also. And I don't know how would you do it, because for quadratic we can do it manually, but for higher orders we need some numerical methods, right? So, but the good part is they're not asking you the roots of this equation. They are only asking you whether it lies on the left and the right. And that can be found using the Routh stability criteria. So this is the Routh stability criteria. So how to write this? So we write this characteristic equation in this form. So this is the Routh stability criteria algorithm. Write the coefficient of this one, 1, and alternate coefficients, 4 and then 3. And this one is -1, -4, -2. Okay. To get the coefficient here, what we need to do is multiply this by this and then subtract this into this divided by this. Okay. So this is -4 plus 4, this becomes 0. So now we are in trouble. If 0 comes, right, everything after this will become 0. So how do you find all the coefficients for this, right? Ultimately, our aim is to find all the coefficients till s to the power 0, and the number of right hand poles is given by the number of times the sign has changed between these coefficients. So that's the rule. Okay. But to find that, we need to first figure out these coefficients in the first row. But we got a 0 here. Then after that, it's very difficult to find, right? How to find? So what we do, so whenever we get a 0, we replace it with epsilon, okay? Where epsilon tends to 0. Okay. So let's keep it at epsilon. What's the coefficient here? It will be this into this minus this into this divided by -1. Same. So -3 plus 2 minus 1 divided by -1, it will be 1. Coefficient here, -4 sigma plus 1 by sigma. Coefficient here, it will be -2 because this into this, and if nothing is there, then 0. We'll assume this into this minus this divided by epsilon, it will give you -2 only. Here, this into this, which is -4 sigma plus 1 by epsilon plus 2 sigma divided by same, -4 sigma plus 1 by epsilon. Okay. And yeah, now let's come to this to power 0. So that will be this into this minus this into this by this, so ultimately this will be also -2. Okay. So now we have the coefficients in terms of epsilon. So let's replace it. So the coefficients are, now you can put back the epsilon value. These are 1, -1, epsilon tends to 0, basically 0. When you put epsilon 0, right, what happens? So this becomes 1 divided by 0. But the term is +1 divided by 0, so it will tend towards plus infinity. And what about this one? Okay. And this one is -2. Let's simplify this. Multiply it by, so I'm trying to simplify it here. 1 -4 sigma plus 2 sigma square divided by 1 minus 4 sigma, right? Where limit sigma tends to 0. So if this tends to 0, this becomes 2 sigma, this becomes 1 by 1. So this is 1. Okay. So how many times the signs have changed? So first sign change was here, then here, Okay, this also you consider 0 plus, right? And next sign change was here. So 2 sign change and then 3 sign change, right? So it means there are 3 sign changes, 3 right hand poles, and the remaining 2 right would be left hand poles. So that's the answer.